Hi, let's solve paper 2 variant 2 of AS level physics today. Question 1, state what's meant by a vector quantity. So that's a physical quantity that has both magnitude and direction. B, a sphere falls vertically through a liquid that has density 830 kg per meter cubed. The sphere has a radius r and constant velocity v as shown in figure 1.1. The drag force acting on the sphere is given by this formula over here, where n denotes a property of the liquid. Determine the SI base units of n. So the SI base units that we are familiar with are kg, meter, seconds, and ampere for the quantities of mass, length, time, and current. And we can find the SI base units of n by first deriving the formula for n by making it the subject of formula. So that would be the drag force divided by 6 pi radius velocity. 6 pi being constant values do not have any units. Drag force, you can derive its SI base units by using the formula force is equal to mass into acceleration. So mass is denoted by kg and then acceleration is meters per second squared. Radius is measured in meters and then velocity is meters per second. You have the meter, one of the meters and one of the per second units cancelling out. So that leaves you with kg per meter per second. State an equation showing the relationship between the magnitudes of weight, drag force and upthrust acting on the sphere. Okay. First off, the weight of sphere acts downwards, and drag and upthrust both act in opposite direction to the motion. That means both of them will be acting in the upwards direction. And looking back at the question, we can see that the sphere has a constant velocity. What that means is, here I want you to recall Newton's first law of motion, which states an object remains at rest or travels with constant velocity unless a resultant force acts on it. That means if the sphere here is traveling at constant velocity, the net force is 0, or the sum of total forces acting upwards must be equal to the sum of total forces acting downwards. So there you go. That's your equation, where weight is equal to drag plus the upthrust. The volume of the sphere is 4.6 centimeter cube. Okay, let's just straight away convert this to meter cube, where 1 meter cube is equal to 1 cm cube divided by 100 cubed, or multiplied by 10 raised to negative 2 cubed. So 4 cm cube is equal to 4.6 times 10 raised to negative square cubed meter cube. The force is given as well. You're supposed to find the weight of the sphere. We just stated that weight is equal to, the force of weight is equal to upthrust and the drag forces acting on the sphere, where drag force is given as 0.32 Newton, and that means you need to find the upthrust. And we learned that upthrust is equal to the density of surrounding liquid multiplied by the gravitational force constant and the volume of the submerged object. And you were given the density of the liquid as 830 kg per meter cube. So there you have 830 times 9.81 times the volume of the sphere, which as we said earlier is 4.6 times 10 raised to negative 2 cubed. And that leaves you with 0.037 newtons. Remember to note your answer in 2 significant figures. Define momentum. So momentum is the product of mass and velocity. Which is why it is also a vector quantity, because it has direction. A child stands on a scooter on horizontal ground. The combined mass of the child and the scooter is 16 kg. The child starts from rest, that means initial velocity is 0 and pushes once on the ground with a foot, which causes her to accelerate. The push lasts for a time of 1.1 second. The speed of child in the scooter after the push is 0.0 seconds. So that's your final velocity here after a certain time period. Determine the average resultant force acting horizontally on the child and the mass during the push. So resultant force is equal to mass times the acceleration. Mass of both of them combined is 16 times acceleration. That's v minus u divided by t, which means 0.6 minus 0 divided by 1.1. And so your final answer here would be 8.7 Newton. Later, the child in B travels down a slope at a constant angle to the horizontal as shown. At point A, her speed is 0.6 meters per second. She has a constant acceleration of 0.85 meters per second parallel to the slope. Okay. I like to denote everything on the diagram that's given in the question. After a time of 3.7 seconds, she reaches point B. Calculate the distance x traveled by the child along the slope from A to B. Okay, so the time period here is 3.7 seconds. Because the acceleration is constant and in a straight line, we can use one of the four formulae. Now you can use one of these four formulae to find your answer here. We are supposed to find the distance, that means you can't use the first one. And given every other information in this question, it makes the last formula the most suitable. So the distance here would be 0.6 times 3.7. And then you plug in her acceleration as well. And lastly multiply that by t squared. So you'll have distance being 8 meters from A to B. At point B, the child in C applies the brake with a constant force to maintain a constant velocity. Okay, so from A to B, her distance was 8 meters. Initial velocity was 0.6 meters per second. She applies the brake at point B and then with a constant force, and then maintains a constant velocity. Point C is 18 meters from point B as shown in figure 2.2. The work done by the braking force between B and C is 250 joules, which is also equal to the energy transferred. Determine the magnitude of braking force. So work done is equal to force times the displacement in the direction of applied force. That means you can find the braking force that's used to do this amount of work over a distance of 18 meters. Pretty straightforward, and that's 14 newtons. On figure 2.3, sketch the variation of kinetic energy of the child in the scooter with distance traveled from A to C. Numerical values for kinetic energy are not required. Okay, from A to B, right, let me just draw this again. That's 8 meters, and then you have 18 meters. Between A to B, or from 0 to x meters, she will accelerate, meaning that her velocity increases at a constant rate. Hence, the kinetic energy will also increase. So that's for this portion. The kinetic energy is going to increase. That means you're going to see a positive gradient. Now let's look at where the starting point for this child will be. At point A, the child has a non-zero kinetic energy value, since at point A, remember, her initial velocity was 0.6 meters per second. That means she does have some kinetic energy. So you won't start at the origin. Instead, you will start at a non-zero value for kinetic energy, and then her kinetic energy is going to increase up until x. So you would denote that by a positive gradient, something like that. And then for the second part between B and C, or from X to X plus 18 meters, remember that the child applies a braking force to maintain a constant velocity, and since KE is equal to half mv squared, if V remains constant and mass is also constant, that means the kinetic energy is going to remain constant. So the kinetic energy will level off right after X, and you will denote that by a horizontal sketch. Question 3. The variation of stress with strain for a metal P is shown in figure 3.1. Point E is the elastic limit. Elastic limit is the point beyond which an object will deform in a plastic manner. So that means if beyond this point you deform an object, it will not return to its original shape once the force is removed. Use figure 3.1 to determine Young modulus for P. Young modulus is equal to stress over strain. Here you can use the graph to get the gradient, or you can use any one specific coordinate as well. I'll pick this one over here, where the stress is equal to 24 times 10 raised to 7 pascals, and then the corresponding strain is 1%. Now remember, strain is equal to extension or change in length divided by original length. That means the units cancel out. You do not have any units for strain. So that means you need to convert the percentage into a numerical value without units. And for that, you would simply divide 1 by 100. That leaves you with 0.1 value for the strain. So the coordinate that I have picked, that's 24 times 10 raised to 7 divided by 0.01, and so that's your final answer of 2.4 times 10 raised to negative 10 pascals. On the line in figure 3.1, draw a cross to show the limit of proportionality. Limit this point Q. Okay, funny enough, it's the same coordinate over here. Limit of proportionality is the point up until which the graph of a force extension graph is a straight line passing through the origin, and after this, when the graph starts to curve out, the extension no longer remains proportional to the applied force. And because stress is equal to force over cross-sectional area and strain is equal to extension divided by length, they can almost be used for they are proportional to applied force and extension, which is why we can use the same conditions in this case. B. State the conditions necessary for an object to be in equilibrium. The two conditions that need to be met are that the resultant force acting on the object must be 0 and the resultant torque must be 0. That is, the object needs to remain in linear and rotational equilibrium. It cannot be moving either in a linear pattern or in a rotationary pattern. A wire is used to hold a uniform shelf AB horizontally in equilibrium as shown in figure 3.2. The wire is connected to the midpoint of the shelf AB at an angle of 50 degrees to the horizontal. The shelf is attached to a wall by a hinge at A. The length of shelf is 0.65 meters and its weight is 33 Newton. Okay, so the weight acts from the midpoint of this uniform object that's over here, which would be at half the distance of 0.65 meters, and that is 0.325 meters. A cup of weight 1.5 Newton rests on the shelf. Okay, so that's this one over here, 1.5 Newton acting downwards with its center of gravity at a horizontal distance of 0.12 meter from B. So that means the distance of this the center of gravity of this cup from A would be 0.65 minus 0.12, and so that is going to be 0.53 meters. By taking moments about A, determine the tension in the wire. So first off, we were informed here that the shelf rests in equilibrium. That means the sum of clockwise moment here must be equal to sum of anti-clockwise moment, since we are going to be taking moments about A. Let's look at what that means for each of these forces acting on the shelf. First off, clockwise moment must be equal to anti-clockwise moment. Now, clockwise moment would be caused due to the weight of this shelf, which acts from its midpoint. So that's moment is equal to force multiplied by perpendicular distance from the pivot, right? So that means for the weight of the shelf, which acts in the clockwise direction, that is 33 newtons times its distance from the pivot, which is 0.325, and to that you will add the second moment that in the clockwise direction, which is due to the cup of the weight, which is 1.5 times 0.53 meters, and this should be equal to the anti-clockwise moment. Now, the anti-clockwise moment here will be caused due to the vertical component of the tension in this wire. Since tension is a vector quantity and you are given with the angle that it makes with the horizontal, let's break it down into its horizontal and vertical components. So you have the horizontal component would be T times cosine 50, and the vertical component would be T times sine 50. And the moment, the anti-clockwise moment, as you can see, it acts upwards. That means the tension in the wire will result in an anti-clockwise moment. The moment due to this will be equal to the sum of clockwise moments. So the force here is T sine 50, and the distance that it makes from the pivot. The midpoint is where the rope is attached. That means the distance we'll consider is from A up until the midpoint of the shelf, which is 0.325 meters. Therefore, tension would be equal to 46 newtons as your final answer. The stress in the wire is 1.5 times 10 raised to 7 Pascal. Determine the radius of the wire. So stress is equal to force divided by cross-sectional area. The force or the tension that we just found in the wire is 46 newtons. Cross-sectional area for the radius of the wire. The shape of the cross-sectional area for a wire is circular. That means the formula for this would be pi r squared. And we are supposed to find the radius here, where the stress is given as 1.5 times 10 raised to 7. That means radius squared is equal to 46 divided by 1.5 times 10 raised to 7 pi. And then to find out the radius, you just take square root of both sides. That means the radius is equal to 9.9 times 10 raised to negative 4 meters. More items are added to the shelf, doubling the stress in the wire. The wire is made of metal P from A. Okay, so the stress here is going to be multiplied by 2. Use figure 3.1 to state and explain the wire, whether the wire will behave plastically or elastically as the stress doubles. Once again, what does plastic behavior or deformation mean? It means that once you remove the stress or the load, the wire should return to its original length or its original shape. And that can only happen if the extension is has not reached the elastic limit. So let's see if the stress value reaches elastic limit or not when it's multiplied by 2 for this wire. We knew the stress here to begin with was 1.5, right? 1.5 times 10 raised to negative times 10 raised to 7 pascals, and multiply that by 2, that would be 3 times 10 raised to 7 pascals. And this is clearly well before the elastic limit. So that means at this value for the stress, the wire will still undergo plastic deformation, or it will behave in a plastic manner and so it can return to its original shape. Question 4a. With reference to the direction of transfer of energy, compare the oscillations of transverse and longitudinal progressive waves. So that's a matter of their definition. Pretty basic. Transverse waves have oscillations perpendicular to the direction of energy transfer, whereas longitudinal waves have oscillations parallel to the direction of energy transfer. A pipe is open at one end and closed at the other with a piston. The piston can slide freely at a distance of 4.5 times 10 raised to negative 2 meter from the open end of the pipe. A loudspeaker is positioned near the open end of the pipe and emits a sound wave of a single constant frequency. A stationary wave is formed in the pipe as illustrated in figure 4.1. A stationary wave or a standing wave is produced by superposition of two waves of the same frequency and amplitude traveling in the opposite directions. That means if two waves of the same frequency and amplitude traveling in the opposite direction overlap, they will result in a standing or stationary wave. Now here you have one end open in the air column. That means the stationary that forms the first harmonic will have a quarter of the wavelength. Keep in mind, for stationary waves, the first harmonic in an air column with one end open and the other end closed looks like this, which is equivalent to quarter of a wavelength. When the air column is open at both ends, here's what the first harmonic looks like. There would be half of a wavelength. When both ends are closed, this is what it's going to look like, and this is also half of the wavelength. Now clearly we are dealing with the first scenario, so let's proceed and see what the question requires of us. On figure 4.1, draw a letter A at position of an antinode. So that's this one over here. Antinode is where the amplitude is maximized, and antinodes occur at open ends, whereas you will see that nodes, which is this point over here, occur at closed ends. The speed of sound in air is 340 meters per second. Determine the frequency of the sound wave. So speed of sound is equal to frequency times the wavelength. That means the frequency is equal to speed divided by the wavelength. Now remember, for the first harmonic, which is shown over here, the length is equal to quarter of the wavelength. Therefore the wavelength over here would be equal to 4.5 times 10 raised to negative 2. So for the frequency, that would be 340 over 0.18 meters, and that's 1900 hertz. Correct to two significant figures, of course. The piston is moved to the left. Okay, the frequency of the sound wave emitted by the loudspeaker is then changed so that the stationary wave is formed with the same number of antinodes. What they're telling you is, if the number of antinodes remains the same, that means the stationary wave now will still have only the first harmonic. The number of harmonics or the number of nodes and antinodes is not going to change. State and explain the change that is made to the frequency of the sound wave. Okay, so here's your air column, and if the piston moves to the left hand side, that means there's going to be more space which will allow this first harmonic to extend. In other words, this length is going to extend, and therefore the wavelength will increase for the first harmonic. And since wavelength is inversely proportional to the frequency, that means the frequency is going to decrease here. Question 5a, define electric potential difference. So that's just energy transferred per unit charge from electrical to other forms, and in terms of formula that would be E over Q, and so its units are joules per coulombs. This is the electrical energy that's provided to each charge from its power source. So let's imagine if the charge carrier or the electron is moving out of the power source, it will be provided electrical energy from the power supply, and then once it passes through the electrical components, it will lose that energy that may be converted to light energy, heat energy, or any other forms. That's what electric potential difference here means. A power supply, 3 resistors and component X are connected in the circuit shown in figure 5.1. The power supply has an EMF of 230 volts and negligible internal resistance. The current in the power is 7 ampere. Identify component X. Component X is a heater. It's one of the circuit symbols that's mentioned in the syllabus that you're required to be familiar with. Show that the potential difference across the resistor of resistance 0.86 ohm is 6 volt. So that's this one over here. That's pretty straightforward. Potential difference is current times the resistance, and as you can see, 7 ampere of current flows through this resistor. So that's your calculation over here. Determine the current I1. Okay, for this one I want to redraw the circuit. So as you can see in this circuit, the 0.86 ohm resistor is in series with the entire combination of other components, where these two are connected in series, and then combined they're connected in parallel with 170 ohm resistor, and then this combination is in series with 0.86 ohms. Now when a current flows through the circuit, it's going to pass straight through the 0.86 ohm resistor. That would be 7 ohms. And then remember Kirchhoff's first law. The sum of currents entering a junction must be equal to the sum of currents moving out of it. That means if 7 ampere is going to enter over here, it's going to split into I1 and I2. So I1 plus I2 must be equal to 7 amperes. Now the value of current flowing through these resistors or these components in parallel is unknown over here. And then according to Kirchhoff's second law, the sum of EMFs around a closed circuit must be equal to 0. We just found that the potential difference across the 0.86 ohm resistor is 6 volts. That means the voltage that is available to the combined resistors over here would be 230 minus 6 volts. So the potential difference across 2.4 ohm X and 170 ohm resistor is 230 minus 6 volts. That leaves you with 224 volts. Now remember that in parallel both branches would have the same value of voltage. That means the voltage across 170 ohm resistor is going to be 224 volt, and the total voltage in the upper branch of these electrical components will also be 224 volts. The difference here is all of the 224 volt of the potential difference is supplied to just one resistor in the lower branch, whereas in the upper branch it will be divided between the 2.4 ohm resistor and the heater. So if you want to find the current in the 2.4 ohm resistor, you would ideally have the voltage across it and then the resistance. Now even though we know that 224 volts of potential difference is available across the entire branch, we don't know what proportion of that is specified only for 2.4 ohms, since it's going to be split with the heater as well. So we can't use this formula directly. Instead what we can do is we can find the current in the 170 ohm resistor. So that would be I2 V by R the voltage across this is 224 divided by its value of resistance, and that's equal to 1.3176. We don't have to work with all of those decimal places. I just like to keep it safer. And then using Kirchhoff's first law, that means I1 plus 1.3 is equal to 7 ampere, and so I1 is equal to the subtraction of this portion from the total current, and that's going to be 5.7 amperes. And the same current will flow through both of the components in the upper branch of the combined components in parallel. Calculate the potential difference across component X. So the current, as I mentioned, is going to be the same in both components of the upper branch. So Ix will be equal to 5.7 ampere. If you want to find the value of potential difference, you need to know the value of its resistance, or what you can do is you can use the fact that both of the 2.4 ohm and X components are connected in series. That means the voltage, the total voltage across them is going to be split between them. Let's put that into an equation. The total voltage across 2.4 ohm resistor and X is equal to the voltage across 2.4 ohm resistor and the unknown voltage for the heater. That means if you want to find out the voltage for heater, you would subtract this voltage from the total voltage. So V total minus the voltage across the 2.4 ohm resistor. The total voltage supplied to the upper branch of the circuit, the upper branch of the parallel combination, remember that was 224 volts. And then from that, now even though you don't have the voltage across 2.4 ohm resistor, you can find that calculating using Ohm's law, IR, remember? So the current is 5.7 ohms times 2.4. The current is 5.7 amperes times 2.4 ohms. So that leaves you with 210 volts for your answer. That's the potential difference across X. Calculate the power dissipated in X. Pretty straightforward. Power is potential difference times the current. So that would be 210 times the current through it, which is 5.7 amperes. And that's equal to 1200 watts. The purpose of the circuit is to provide power to component X. Determine the percentage efficiency of the circuit. So percentage efficiency is equal to useful power output divided by total power input times 100. The total power output, as we just saw, is 1200 watts. And then the power input, again, you can use the same formula. VI, the power source, is 230 volts, and then the total current in the circuit is 7 amperes, which you can put that into the denominator over here times 100, and that turns out to 75% of efficiency, correct to two significant figures. The resistor of the resistance 170 ohm is removed. So that means this lower branch over here, okay, leaving an open circuit in the lower branch of the circuit. There is no change to the resistance of component X. State whether the current in the power supply increases, decreases, or remains the same. Okay, let me draw the circuit once again over here. Okay, so this was the initial setting, and now you have the new setting over here where the 170 ohm resistor is removed. As you can see, this will leave an incomplete pathway, almost like an open switch in the lower branch. What that means is all of the current will now be directed through the upper branch. So let's imagine if you had the total current of 7 ampere, it would have flowed through 0.86 volt and then splits at this junction, and then it combines once again back at this junction, flows back to the power supply. However, now what's going to happen is, once the current reaches once it has passed through 0.86 volts, it's not going to flow through the lower branch because this pathway is incomplete. All of the current is now going to flow through the rest of the electrical components. That means the current through 0.86 volt, 2.4 ampere resistors and X will be the same. Now, other than that, let's look at how the value of resistance changes. Also keep in mind the new value of current will be different. Why? Because previously we had these resistors and the heater combined in parallel. That means the total resistance would have been smaller. Remember, the total resistance in a circuit is always smaller when some or all of the electrical components are combined in parallel, in comparison with a scenario where they are connected in series. So now in this new combination, since the components are now connected in series, the total resistance is going to be much larger. That means the total current will be smaller than the previous 7 ampere. And so that's it. This is why the current in the power supply will be smaller in this case. Question 6a. Compare an alpha particle with a beta plus particle in terms of their masses and charge. So an alpha particle is almost like a helium nucleus, which has 2 protons and 2 neutrons, and as you can see, that's a total of 4 particles with 4 atomic mass units, whereas beta plus particle is like an electron but with the opposite charge, and it has negligible mass. So an alpha particle is much heavier than a beta plus particle, and then alpha particle with 2 protons will have a charge of +2, whereas beta particle will have a charge of +1 only. Nucleus P undergoes alpha decay to form nucleus Q. Okay, wait. The proton and nucleon numbers of P and R are shown. So P with the nucleon number 216 and proton number 84 will undergo alpha decay. That means it's going to form a helium nucleus. Okay, let's just denote that by alpha, which has a mass number of 2 and mass number 4 and proton number 2. And then it's going to result in nucleus Q, which will have a smaller mass number. You'll subtract 4 from 216 to get the mass number of Q, that would be 212, and subtract 2 from 84 to get the proton number of Q. On figure 6.1, draw a cross to show the proton number and nucleon number of Q. Label your cross. So that is going to be this one over here, Q. State the names of the particles emitted as Q decays to form R. So Q decaying to form R, the mass number remains the same, 212 as you can see. However, the proton number increases from 82 to 83. And this happens when a nucleus undergoes beta minus decay. So Q will undergo beta minus decay, which does not have mass number. However, it does add to the proton number. So that will form R, as well as emitting electron and neutrino particles. So you're supposed to mention that over here. Beta minus or an electron. I prefer to write electron over here with an electron antineutrino. before the alpha decay, P is traveling at a constant velocity. After the decay, Q has a velocity of this magnitude and at an angle of 68 degrees to the original path of P. So original path of P was only in the horizontal dimension. The alpha particle has this velocity at an angle theta, which is unknown to the original path as shown in figure 6.2. Use the principle of conservation of momentum to determine theta. So according to principle of conservation of momentum, the total momentum before explosion is equal to the total momentum after explosion. Since that's what's happening over here, the particle splits into two. And because particle P is only shown to have horizontal momentum, that means the vertical momentum before explosion must be 0. And because momentum before explosion is equal to the total momentum after explosion, that means the vertical momentum after explosion must also be 0. Now that you are given with the angles that the velocities of these particles make with the horizontal, let's split them into their horizontal and vertical components. So once again, the horizontal component would be, and the vertical component would be 150 sine theta. Similarly, for particle Q, the horizontal component would be V times cosine 68, and then the vertical component would be the velocity times sine 68. Since we don't know the horizontal velocity of P before the explosion, we can't work with the horizontal components. Remember, momentum is equal to mass times velocity. If you want to work with these variables, you need to know both of these values, which is why we'll be looking at the vertical component. Right, we don't have the horizontal momentum of P, which is why we'll be looking at the vertical components, because we know for sure its initial vertical velocity is 0. So if you say that total momentum before explosion must be equal to total momentum after, we know that in the vertical dimension that is 0 before the collision, and then after, it's due to the vertical components of velocity of particles alpha and Q. So what does that mean? For alpha, let's say that's mass of alpha particle was 4 units times the velocity. Since we are looking at the vertical component, that would be 150 times 10 raised to 5 sine theta. And now to this you are supposed to add the momentum of particle Q. There would be so particle Q has a mass of 202 units times its velocity, which is 1.3 times 10 raised to 5 sine 68. Remember, we are considering the vertical component only. Now, because this velocity is in the opposite direction to the velocity of alpha particle, this is going to be negative. Remember, velocity is a vector quantity. So in other words, 0 will be equated to 4u 150 times 5 sine theta minus 212 units multiplied by the mass multiplied by the velocity. And because we want to find the theta, you would just shift the negative portion of this equation to the left hand side. That means okay, so those would get cancelled. That means sine theta is equal to and then theta is sine inverse of that, which is equal to 25 degrees. corrected to two significant figures. Calculate the kinetic energy of the alpha particles. Well, kinetic energy is equal to half mv squared, and the mass of an alpha particle is 4 atomic units, so that's 4 times 1.66 times 10 raised to negative 27 multiplied by its velocity squared, and that's equal to 7.5 times 10 raised to negative 13 joules. And that is it. We are done with this paper. Thank you for watching.